open source is about the integrity of the author's code, which means whoever created the software is recognised as the creator of their code. Hero! And they may ask anyone who modifies the code to use a different name for any new version of the code they create. That will stop any confusion between the two pieces of software once the code is modified to make something new. You already know how to modify code. That's super cool. Sometimes we modify code and instead of creating something new with a new name, we collaborate with others and add it to an existing open source project. Open source developers do this all the time with the code that they create. Do you know how to contribute a suggestion to an open source project and to collaborate on code? In the last course, Ronan and Rhys collaborated on code in lessons 9 and 10, and Rhys modified Ronan's code. They shared the modification at school, but software developers shared their code and modifications in repositories. In open source, we use public repositories like GitHub and GitLab to manage code and people's contributions. Public repositories, or repos as we call them, can be seen by everyone who has an account. The public repos host thousands, in fact tens of thousands of projects on their repos, allowing distributed collaboration. This is how open source projects manage their projects. Having an account is age restricted on these repos, like most online services. So we won't use them to modify and share code in this course. But don't worry, we will do some work on modifying Python in this lesson. Did you notice that the repo names both started with Git? Is that a coincidence? Git synchronizes everyone's contributions to the collaboration and allows developers to have a local version of a file on their own devices. When you use Git in code development and you're happy with the code you've written, then you can share it by committing it to the project using the repo. If the project decides to accept it, then it will issue a pull request and it will become a part of the open source project and other developers will be able to see and use it. More than one developer can work on code at the same time using Git. By doing this, developers avoid having to work out how to merge all their different changes and contributions, as Git automatically does that for them. Phew, that's handy. Git also shows all the history of changes that have been made to the code, so it creates a record of all the contributions. The good news is that Git's not another language you have to learn. But if you want to be a developer and contribute to code, you will need to learn how to use Git. Do you remember our friend Linus Torvalds, who created Linux? Well, he also created Git. GitHub has a really cool logo, the Octocat. When developers work on GitHub, they use stars. They use them like bookmarks or to show that they like other developers' projects. Sometimes people actually become a GitHub star. We have GitHub Star of the Year, Eddie Jaoud, in our e-zine for this lesson. He even makes some money from putting his code on GitHub. When we create something new, say we make the code achieve a different task, although we might change the software's name, we keep the details of the original creator of the code. We amend the name on the new code, but recognise the original contributor. Giving them credit for their work in this way is called attribution. We attribute anyone whose code we use and recognise their work. We do that in the copyright notice in our code. But we don't take their project name or brand if we make changes to code. We can think of naming like an ice cream cone. Just the cone is a cone. Just the ice cream is ice cream. But the new thing together, as a new name, it's an ice cream cone. The bits exist on their own and together make something new with a different name. So if we take an ice cream cone and modify it by adding a flake, then we don't call it an ice cream cone anymore. Now it's a 99. I can hear an ice cream van. I'd love a 99. Do you remember we talked about licenses when we shared the jumper in Lesson 1? When licenses require us to give our modifications to the original code creator, they are a special kind of open source license called a copyleft license. If you contribute enough of these modifications, you could become a GitHub star or even a coding rock star like Eddie. By the end of the lesson, you will be able to understand the importance of contributing to code, understand what Git is and how developers contribute code to repositories, create a Python program to make the microbits speak, know a little about repositories and contributing to open source projects. Last lesson, I promised we'd be programming the glove with Python to do something that MakeCode can't. And here it is. We're going to be making our glove speak. So, let's start by opening up the MicroPython editor at https://python.microbit.org/v/2. We're going to use it to help us today, and you can find out more about editors in the e-zine. If you get a bit stuck, you can always check the documentation. The documentation is a document which gives all sorts of useful information about how to use libraries. If you want to access the documentation for the microbit Python library, you can click on the Help button and then the documentation link. Like the last time, we need to import the modules we want. Of course, we want the microbit, but instead of music, this time we're going to import speech. Let's create a new variable called name and set it equal to your own name. Don't forget to put the quotation marks at the start and end of your name. This tells the program that the name variable is a string. Let's get the microbit to say its first word and say hi to us. The next line is quite tricky. One downside about text-based programming languages like Python, you need to spell everything correctly or the program won't understand. We don't have this problem in MakeCode because the blocks are always spelt correctly. When you're done, save your program and copy it over to your microbit, just like we did last week. Looking at our speech.say command, we can see that there are loads of things we can change like pitch and speed. Try playing around with those values and recopying the code onto the microbit. How does that change how the sentence is said? You might also find it says your name a little weirdly, so try playing around with sounding out your name to fix that. How we phonetically write the word can help the device to speak it out loud correctly. So if we ask it to say the name Loena, we can write this as Lo-e-na and help it to get the name right. Oh, a wee glove can speak. Okay, just like last time, let's create a forever loop using while true. Now we want to write some code to deal with these three cases. If the microbit is shaken, if it is tilted left, and if it is tilted right. Just like in MakeCode, we'll need an if-else statement. Do you remember last time we used the expression accelerometer.wasGesture? Let's think a little about what that means. Say we have a dog and our dog knows 3 tricks. Sit, lie down and shake. Say we then want to tell our dog to shake, we can use the expression dog shake. Now, looking at our code, instead of dog, we've got accelerometer. Our accelerometer knows certain tricks, just like our dog. The one we're going to want to use this time is was gesture. Do you remember the last action you did with the glove? This action is what is stored in was gesture, and we will use it to decide what happens next. If the last action was shaking the microbit, we use speech.say to say, sustainability is important. Aha! Did you see that? Speech.say. Can you guess what that means? What other tricks do you think the speech module allows the microbit to do? Don't worry, we haven't forgotten about was gesture. Within the brackets for the was gesture statement, we have the word shake. This tells the program we are looking for the shake gesture from the microbit. So that's our first if condition. In our next statement, we use elif. Take a guess what it stands for. It's a shortened version of else if, just like you've seen before in the MakeCode editor. Our next statement involved checking if the microbit was tilted left, so the left in the brackets. In the next speech statement, try writing, I love to use the Mini-Mew glove. Finally, we want to write one last elif statement to check if the microbit has been tilted right. Instead of left in the brackets, we now have right. Pretty logical, huh? When you're ready, hit the save and download your code to your microbit. If we were adding this to an open source project, we would go to the repo and submit the code as a pull request or a patch. If the contribution is accepted, it becomes a project commit. And that's how we're going to become stars. Open source projects are made up of thousands of people all over the world contributing their code on these public repositories. They bring diversity to the project they create, with all of their cultures and backgrounds from around the world. This diversity is important because it helps us to make better code. It also allows people to learn skills from each other too. Lots of people in open source projects contribute code as a hobby in their free time and keep learning as they do this. Many of them become paid developers later. Developers work all around the world, wherever they happen to be, and they did this even before the pandemic. SDG 8, Sustainable Goal 8, is about creating decent employment for people, and Goal 10 asks us to reduce inequalities. Working in open source software development can help achieve that. This is great for all of us. We get to meet really interesting, diverse people, and their lives are made better by coding. In this lesson, you have learned to understand the importance of contributing to open source code, understand what Git is, create a Python program to make the microbit speak, understand a little about repositories and contributing to open source projects.